contour lines. They're one way to show a height on a 2D surface like a map, and they show different heights. The closer the contour lines are together, like if they're really close, that means that it's going to be really steep incline. Yet if the contour lines are further apart, then it's going to be a really shallow or low increase. And they're used in lots of maps to show all different types of hills and valleys. And they're used by lots of people to do lots of mountaineering.
But why? I think the key thing is why would a contour map be useful for a...
Well, if you're going out hiking or something, you know different heights of the map, how steep the hill is going to be, how...
yeah, excellent. Perfect. Excellent. Good work. Good work, Clay.
Onto transpiration. Transpiration is the process by which moisture is carried through plants from roots, small pores on the side of leaves, where it changes, it's released to the atmosphere. Transpiration is evaporation of water from plant leaves. Transpiration also includes a process called vitation, which is the loss of water in liquid form from the uninjured leaf or stem of the plant.
Cool. So how would you sum that up, maybe a little bit simpler to remember?
Transpiration is just practically moisture coming from plants that go up into the atmosphere.
Cool. Yeah, that's really good. Cool.
Okay, so I did a low pressure system. A low pressure system is when the air rises and it produces cooler weather and rain and wind, and the wind rotates clockwise in these areas. There's little numbers. I can't really get the picture, but when there's a weather system on a map.
You can show the picture in front of the camera.
Okay.
Yeah, what are we looking at?
If there's like the little numbers on the ISO bars are the weight of the air and the pressure.
Mm-hmm.
So the average is 1013, and this is okay.
Oh, keep talking.
Okay.
Doesn't
Okay. The okay.
There you go.
Okay. So these are ISO bars, and the little numbers by the ISO bars is the weight of the air. So the average weight is 1013, and this is 1012, so it's below average. And
Oh, that's good.
Yeah.
Good work. That's all right. Good job. All right, so just flick it up, Matt. You flick your four fingers up, and then you just turn it off.
Okay.
And then click iPad at the top. At the very top. Yeah, you go. Good work. That's okay. You smashed it, man. It's working well today, which is good. So can group 2 prepare near the door and get ready to head up? Because we're just going to churn through these. Because I want to make this a really nice short video so you can watch it quickly. Nick, Nucky, move. I was going to say Nick off Nucky, but then I just got Nick Nucky. All right, here we go. So, guys, just before Jared goes, I know that some of you are doing this six-figure grid referencing a few times. Okay, again, it's because it's quite interesting, it's quite important. We went over it a few times, and I know some of you were still a bit stuck, so that's why I want a few different interpretations from a few people. Sorry, go, Jared.
So I'm doing six-figure grid references, and this is basically the one from the book that we're using. So how you make six-figure grid references is firstly you do your E-sticks. So how I remember it is walk before you climb. So the first two numbers. So with this one it's 18, and then 5, which is because the square is supposed to be divided up into little sections. So 5 would be in the middle, and then you go up, and you've got 44, sorry, and then 3. So if it was like a little dot, it would probably be about there somewhere. Yeah, that's how you get a six-figure grid.
Cool. Excellent. Your group done? Good work, guys. Awesome. All right, let's move on. Let's go straight to group 2. We'll clap at the end. because you're all winners. Because again, I want this to be nice and quick and concise so you guys can watch this during the week. All right, let's go. Group 2. The things you were looking at.
Well, the first thing we did was the centre. What is the centre of the cyclone called? And the centre is called the eye of the cyclone.
Why would you need to be called the eye? Just adding.
Because it's a middle, and because it's like a circle.
I mean, I don't know. I'm just asking.
And the eye is the calm part of the cyclone. And
Why is that?
Well, because everything rotates around this centre.
Yeah.
Point.
So it's passing over, it's calm, then it comes back over again.
It's like
I'd like this little picture.
We'll come back. All right, keep going. Good work. Thanks, Nucky.
And I also did absolute distance,
Mhm.
and it's the exact distance. For example, like when the distance between Earth and Mars, when they're the closest point together, is 54.6 million kilometers, and then the farthest away they are, when the longest distance away, they are exactly 401 million kilometers, and the average distance is 225 million kilometers, and that's absolute distance.
So to sum that up in a non-Mars example, how would you? What would you say absolute distance is?
Distance between Sundry and Goose Creek would be like, I'm not sure.
It wouldn't be. It would be like. It would be. It is exactly 20.6 kilometers.
No, that's too long.
It's an example. No, you can't say it's not about. It's not about.
Exactly 14.86.
Okay, cool. So it's absolute. What do we say? Remember with absolute and relative? Absolute, absolutely. Okay, so it's absolute. It's exactly. It's not your cousin. Then it's relative. Yeah, he's all right. You know. All right, cool. Sorry, keep going. Group 3, can you prepare down there? All right, go guys.
Zero now.
So
And quietly, please.
I had absolute location. Absolute location is a location that must be absolutely correct. So the absolute location of Brain College is 1499 Mount Macedon Road, Mount Macedon Vic 3441 Australia.
Cool. And what other examples could you use to get absolute location of Braemar, maybe? Like GPS locations and yeah, 6-figure grid references, stuff like that. Cool. And I'll interact one more time too. So obviously, absolute location and absolute distance are different. Exactly, they're different. Good work.
And I have 6-figure grid references.
Yep.
So firstly you do the eastings and then the northings.
Guys, quiet please.
Some pictures. So,
That's okay. Nucky, can you not make out with Barbara Streisand, please? She's a dear woman. Don't make out with her. No, this is going on the internet. 21st birthday party. Nucky's making out with Barbara Streisand. All right, let's go.
so if we were to do the pink one,
Mhm.
we would start with the eastings. So it would be 18, 9.
Yep.
And 44, 2.
Excellent. Now, because they didn't rate it last time, if you were to write that down, how would you write that down on paper?
You would write it like 18, 9.
But you do one thing.
Oh, you need the GR.
Yes. Okay.
And also-
Always remember that.
Can I ask a question?
No.
Jared said the wrong thing.
Always.
That plane goes forward.
Yes.
Well, that's my quote, and I've copyrighted that. All right. Good work. Continue.
And I have one more.
Yep. Yeah, I don't want to see those pictures. Just cancel. There you go. Puppy.
Yes.
Cancel. Nucky, try and be a little bit serious, okay?
So, I've got this picture of the video on the book.
Yep.
And so for A, you would still like, even though the easing numbers are on the top.
Yep.
You would still use that.
Yes, good.
So it would be, we go, what, yeah, so it's on that line, so it would be, and like it's right there, so it's like, it would be 0, so 97, 0,
Mhm.
and 28, 0.
Yeah, perfect. And you'd put in front of that, you would put
GR.
GR. Excellent. That's really good. That's a really good example where, again, if the eating is on the top or on the bottom, it doesn't matter. They always go first. Good for pointing that out. Go, Samo.
A high pressure system on a weather map basically looks like a map written on a contours map. So there's the line is sort of like further apart than as it gets more towards the higher.
Do you have an example you can show us?
Not really.
Can you draw an example? Yeah, you can. You know what it is. It's fine.
Just like that, so the high pressure system would be so that'd be like the high pressure system. There might be like another high pressure system over here.
Cool. That's good. So essentially, the H is what we're talking about there,
Yeah.
or the
Or
H.
maybe a low pressure.
Yep. All right. Cool. Good. Head back. Head back to the wall. Is that it?
No.
Yep.
Precipitation is any form of water that falls from the clouds when it gets too heavy. They don't really have precipitation such as rain, sleet, and hail.
Yep. What's the word we use for precipitation most? Is what?
Rain.
Thank you. All right, hold on. There's. All right, we get the point. Good work. Lucky, out of it. Lights back on. All right, thank you very much, group 3. 2. All right, group 3. Oh, we better get a cracking on. All right. All right, let's go, guys. Remember, you need to be quiet or you won't hear this stuff when you play the video back, which will be to your detriment. Hold on. Okay, group 4, can you please get ready near the door? All right, quiet everyone, please. All right, ooh, fancy.
These are two examples of common contour patterns. So saddle, which is where two areas of Thailand with a dip between them, illustrated by two circular floor lines with a gap in between. And a valley is lowland between hills or mountains that usually has a river flowing through it. Contour lines form a V or a U shape that points towards Thailand.
Cool, so everyone understands what contour patterns are? Especially you, Ashley, who's still talking, yeah? Ash, do you want to explain what 2 common contour patterns are? Without reading Ashley's work up there.
One is a saddle, and that's where the two mountains meet and it kind of goes up still, but lower than the mountains. And another one is called a round hill,
Oh, we got it with the round hill.
and it's like it's basically a hill that just goes straight up.
Cool. So, lucky. So essentially, common contour patterns, patterns you see on a map, those contour lines you see on a map, okay, and they represent something. So a round hill, you see the contour patterns of a round hill and you know, oh, that's what that landform is, okay? Cool. These are two good examples. Oh, and here we go. Cool. Way to use those ICT skills.
Alright, so what is volts? So volts is pretty much just it's an anagram for what you need on a map to make a map. Pretty much. So B is the water, so we put up next one. Yep, alright, so this is correct like that. So you can see the water, it just goes around the side. The arrow orientation shows which way the map is facing.
Was it generally always pointing north and facing up?
Generally it's pointing north, and north is most of the time pointing
Yep.
up. L, which is legend, so for a correct map, you can see it here, so the different colours show different heights.
And say for a topographic map, that would be slightly different, wouldn't it?
Yeah, show.
Like trees and yeah, cool.
The title, so I've got correct map of Hawaii Island.
Wait.
Scale, so you've got the scale there. So about on most maps, A4 paper, you have like what, 5 centimeters equals 10 k's or something.
Okay.
Depending on how you scale the sources.
That's cool. Yep.
And then the source, which is figure 3, but it's from the book as well. So when you put your source down there.
That's awesome. That's a really good example.
So what are isobars? So isobars are just lines of connecting pressure. So they're like the contour lines which show relief, but in the air, and they're invisible. So you can't see them, but the closer the isobars are together, the stronger the winds are, and the further apart they are, the slower and softer the wind is.
Cool. Good example.
Yeah, so you can see that in there,
Yeah.
it's a lot more calm, but really windy through there because the isobars are really close together.
So the isobars are the lines with the numbers on them. Yeah, cool.
And the numbers show the crash.
Excellent.
Alright, so here there are 4 natural disasters. So with floods, they're caused by too much rainfall or a lot of rainfall, and where there's like lots of water, and then the rain adds to that water and overflows, causing a flood.
Sweet.
And blizzards are caused by like high winds that go over 56 kilometers and lots of rain, snow.
So they have to generally go over that 56 to 60 kilometer speed to be classed as a blizzard, is what we're saying? So that's probably important to know, yeah.
Well, earthquakes and tsunamis are generally caused by the same thing. So they're caused when tectonic plates are underneath the Earth's crust, and they crash together, which either make the land like shake, which is an earthquake, or the sea rises and like goes towards the land.
So words again like tectonic plates, you'd probably use those in your exam than things like if the earth shakes or if the earth hits together. You know, you'd want to try and use those words like tectonic plates because that would be important and interesting.
Relative distance is distance measured in time and cost, but not miles or kilometers. For example, the bakery is 30 minutes away from the United House.
So you've said cost. How would you explain that? How would you define that?
I just, around 5 minutes ago, just before the presentation, I just listened time again because I remembered it, then I forgot it, now I remember it again.
Yeah.
So I can't remember cost.
Okay.
It'll come.
We'll come back to that because that's a good example actually. So does anyone have a go? Have a guess at how could you measure distance in cost? Tess?
Like it's $12 worth of petrol away.
Yeah, I could do that. Anyone else want to have a go at it? All right, maybe that'll be a question for the blog I'll put up. Okay, because that's a good example. Seth?
Maybe someone's like really crashing, really like
It's not burnout paradise.
but like $12 million
Worth- Okay. Yeah, we'll definitely make that a question for the blog. But good example. Cool. Is that it? Oh, sorry, keep going. Relative. Freak Street.
It's 10 miles away from the abandoned house of the single precinct. So it's like near a place, but you don't see the actual address or the place.
Yeah. So how? Give me relative location of Braemar.
It's 5 miles away from the tree, isn't it? To be there.
That yeah. See, you wouldn't say. I wouldn't advise you saying it's 5 miles from a tree, because there's a lot of trees around here. You want to give it relative location to another area that you may know. So I would say for Braemar, it is halfway up Mount Macedon Road, heading west from Woodend or something like that. Like locations that are known. So if I was to give relative location of Mr. Deer's office, okay, I would say it's in Braemar House, just near the end, near the Register's office. So I'm comparing it to something else. So you really want to compare it to something else that you kind of know. Okay, cool. And another little picky thing, you probably wouldn't write miles in our exam. We'd probably do kilometres, yeah? Yeah. And look, I'm just saying. Cool, excellent, good work. So group 4, yes? Excellent, 4, so 5, get ready. What are we looking at time? We need to pump this out in 10 minutes. We can do it. Cool, here we go. So speak up, Elizabeth.
So mine is 3 natural features that you can find on a topographic map. I said you can find lakes on them, which are big blue dots or anything.
Commonly big blue dots, but if this was a black and white map, it probably wouldn't be a blue dot, would it? Yep.
Forests or parks, which are green. And mountains normally. This one doesn't really show many big mountains, but you can normally see.
Cool. And that's, what kind of map is that one, sorry?
Topographic.
Cool.
And I did what Lucas says what was writing on the road map.
Yep.
Similar to writing on the road map, we have straight diagonal lines across the area, like going across.
Do you want to draw it? Pen somewhere? There was a whiteboard marker. Sammy, what'd you do with the whiteboard marker? There you go, quickly draw it. Right, on your side, Bryce.
Just so like, for instance, like, without things in place,
Mm-hmm.
the line can go across like that.
Cool. Perfect. Done.
I did Logos, and Logos means like showing colours to show height, show the place, and so I just really certain
Check over. Yoink. Cool.
So you have the legend up here of what the colours actually mean. So like that's 300, and it just shows the height better than just looking at like a contour line.
Yeah.
Easier.
Cool. Obviously, we're talking about it in relation to height, but you can use it for other things, can't you? Choropleth maps. You can use them for other.
Yeah, I guess probably use it for distance or something.
But you could use it for lots of things, couldn't you? Remember we looked at a few examples like where people voted, stuff like that. So we're using it for height because we're doing height, obviously. But yeah, you can use that kind of mapping for a lot of things. You can have a map of Australia and you can show here are all the tall people, and you have a colour group of tall people, and here are all the short people. Or here's the wealthiest parts of Melbourne, and you could have that in a choropleth too. So it's a visual way of showing data. Sweet.
Alright, well, talk about CC grid references. So what you basically have to do is a grid inside a grid. So that grid number might be 18 and 44. So first you do the eastings, and for the red dot that would be 18, 5, and then it would be 44, 3. And if you wanted to write that grid reference, you'd have to put a GR in front of it.
Sweet as. Those little 1 to 10, will they be shown on a map normally? So your numbers inside that grid, you've got those lines inside the grid.
Yeah.
Would you normally see them on a map?
Sometimes, no.
No, you wouldn't. So you need to figure those out when you do your. So you have your normal grid. You generally won't see numbers 1 to 10 in there. You need to kind of figure those ones out.
Yeah.
Cool. Done? Sweet, let's do it. All right, group 5. Let's go, group 5. Group 5 is up. Group 6, can you get ready near the door, please? Are we getting a dance out of you guys? A play of some sort? It's disappointing. She's your muse. All right, let's go, guys. All right, guys. Reece, you need to really speak up for this one.
Okay, so why do we use contour maps? Contour maps show a realistic view of the landscape. They show detailed elevation in mountains and hills. It also shows valleys, slopes, indentation, depression, and vegetation.
What's depression? I mean, unless the mountain's just really upset with itself, which it could be. It's like, yeah, I'm a mountain. I got nothing. No, so depression. So depression is, did you say like a dent? Yeah, we're getting there. All right, that could be another blog question. Cool. Yep. Yep. Cool. And like I was saying last time, obviously when you see a grid, you won't be seeing those numbers 1 to 9 written in there, okay? So don't be expecting, if you ask to get a 6-figure grid reference, don't be expecting to see 1 to 9 written in your grid. You need to figure that out. And you need to kind of do it accurately. Awesome, thanks, Morel.
What are northings and eastings? Northings and eastings are lines that are on maps, and northings run vertical and eastings run horizontal. They give location on maps. Eastings come first if you write a grid reference. How you remember this is a plain route stored before it takes off.
That's a great quote. Where did you get that from, Jack?
I don't know.
Yeah, whatever, go away. All right, Reece, go.
What are ground fires? The ground fires is when a part of the bushfire travels along top trees. They can travel quick, and they're called crown bushfires because they travel on the crown.
Forest. Crown being top. Good work, guys.
What is climate? Climate is the average temperature of places and it takes studies of people down to
Cool. Excellent. Does everyone get that one? Because that's kind of a good one. And I like how you said at the end it can change. Reece is right. It can change, but it does take a long time. So what would the climate of Victoria be? Well, no, because climate covers the whole. So what's the climate? The average climate of Victoria? Yeah, we're generally what? We generally top out. It's rare that we get 40-degree days. Our average temperature is probably what, 21 or something like that. So it's generally a cool climate. So you can use climate in other, like you could say, what is the climate of Wood End? You know, you can narrow it down a little bit as well. Or what is the climate of Alice Springs? Or what is the climate? So you can narrow it down to certain parts. And I think another group's going to talk about climactic zones. Wow, sounds exciting in a second. Yes, really good. So the average weather. So average is the key. Excellent.
Do we get tornadoes in Australia? If not, why everywhere in America? Tornadoes aren't as common in Australia as in America. We get about 16 tornadoes a year, and they mainly occur around southeast coast of Western Australia, southeast and South Australia, and California to nearby Victoria. And the area around southeastern Tasmania and the far northeast of North South New South Wales, where the venom and tornadoes.
Awesome. Excellent. Brilliant. So we do get tornadoes in Australia. Cool. All right. We'll go to the next group. Sorry, I'll probably keep you in a couple of minutes, but I think this is pretty important that we finish this. I promise I'll make it up to you Tuesday. I promise. I know I already owe you like 15 minutes, but hey. Let's go. So your group 6, so 7 and 8, get ready, and then we'll get out of here. No, I just want to be really quiet until we get this done. It'll only be like 5 minutes, and I promise I will pay you back. Double it. And of course, you get a good mark on your exam, so, you know, win-win. All right, guys, this is important, this stuff. Go, 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 go. Quiet, guys, you need to really be quiet. Sorry, keep going. Sorry. Man-made features, easy one. Features made by man.
So, for natural disasters, bushfires can be caused by wind, humidity, and lightning.
Yep.
Tsunamis can be caused by earthquakes and underwater landslides. Blizzards can be caused by snow on the ground being picked up by the wind. And earthquakes together.
Cool.
Orographic rainfall is when water evaporates.
1 second, guys. This is really important and interesting.
Is when the water evaporates into the air and it gets taken over to a mountain and the mountain blocks its path, so it's forced to rise and that presents a rain cloud and then it rains.
Why would this be important to us right now? Where do we live? We live on a mountain.
Yeah. And it's like it's really cold at the top of the mountain.
Exactly, which is also important to us. So you could say that the rainfall in Mount Macedon or around Braemar, we would typically get that kind of rainfall. Cool.
And so the difference between weather and climate is like climate is what the weather is.
No, I just like the balloon.
Usually, so it's like what is normal, and the weather is when it changes. Like, so, say in the desert, the climate would be like hot, dry, and the weather would be like it could rain.
Another super important one. Did you get that, Jordan? Did you get that one?
No, it wasn't listening.
Difference between weather and climate?
Ooh, I don't think I was listening. Give me back.
One more time, Steph. Do you want to explain that real quick?
So the climate is like what it usually is, and the weather is because the weather changes.
Easy one. Okay, so let's take Alice Springs. All right, the climate is generally a hot climate, yeah? But today it's raining, so the weather is rainy. Easy to remember that one, yeah? Sweet.
And people who use contour maps are hackers, builders, tourists, campers, and pilots because they need to know, especially pilots, because they need to know where the mountains and hills are for their flight.
Would be good. Excellent. Thank you very much. All right, really, really good. So group 7 and group 8, and then you're out of here. Like I said, I promise I will pay you back next class. We'll get out of it 20 minutes early if we have to. All right. Yes, as long as you watch this video later. No.
I was going to say, what's so funny about the rain?
I just saw the balloon was funny. Let's go to the toilet. All right, guys, quick.
Quickly. Hurry on. I am not.
Who got help is lost on airplane?
Steph, is your iPad still connected? Berg,
Oh my god, Ferg.
guys. I just thought it would kick you off. Mustn't.
You actually can't keep people off.
I thought you can't kick people off then.
You used to.
Yeah.
But maybe like maybe kids were kicking off teachers.
Do you want to keep talking about something else while we're waiting for the?
Nah, but all focus on that. It's so we're recording. Be quiet.
It's just for their exam, so they're focused. All right, do you want to maybe skip it for now, Ash?
Yeah.
Cool, just talk. Let's go.
Our first question was what are the continents of the world? So we've got 5 continents. The first one's Africa. The next one, it's sort of two, I guess, but North and South America. Then we've got Antarctica, Europe, and Australasia. And then our next question, world natural disasters. We have to choose 4 natural disasters and how they're caused. So, Drew, just know.
Two tectonic plates clash together under the seabed, causing a huge wave to float over the beach and travel inland, sometimes destroying everything in its path. That's English.
Thunderstorms up in the cloud. Well, this is how lightning is caused because it kind of remains from them. There's water and ice particles flying around, hitting into each other. They cause static electricity, and it needs to escape, so it forms a lightning bolt, and lightning bolt will have the close to positively charged thing, and that is caused by the air because the lightning bolt so hot the air around it expands so fast that it explodes and causes pain.
Floods occur after rainfall on public ground after the water overcomes all the water that flows down the mountain. It goes everywhere and drowns low areas of the closest towns.
Cool.
What is infiltration? Infiltration of water is the absorption of water or the downward movement of water, so maybe we're going into the ground, so it infiltrates into the ground.
Okay, so it's sort of hard to say what this question was asking, but it was asking, so Woodend is local and Bastion and Regis is regional, but it was asking what was next. And what's next is state, and that's an example of which human civilization is classed. So, example is local is just the town you live in. Regional is the group of towns around your town. State is the whole area on a large scale. And then,
And you could keep it going, couldn't you?
national,
Yeah.
National,
Sweet.
National, global.
Cool. That'll be one that we'll focus on. We'll focus that in the blog too. Awesome. All right. Excellent. Last group. Like I said, I owe you half an hour, so we'll do that. We'll do that next class. Let's go. Well, this video is more important than anything, so I would advise watching this for your exam. All right, here we go. Sorry, guys. Let's do it really quickly.
So one question was like oceans, like all the oceans of the world. Like, what are the oceans of the world? So the oceans of the world are the Atlantic Ocean, the Indian Ocean, the Pacific Ocean, the Arctic Ocean, and the Southern Ocean. And remember that oceans are the large bodies of water surrounding countries, not the and then the question was like, what is a climatic zone? So a climatic zone is pretty much just what the name says. It's just an area where there's a certain climate, and the climate is just like what the weather in that area usually is.
Runoff is when the soil in the ground is so saturated that the liquid sits on top of the soil and is soaking it. It then floods the area and flows down hills, hence we call it runoff. The water cycle is fairly simple. The sun is very hot, so it makes the water on the top. The water evaporates and forms clouds in the sky. As the clouds get denser, they get heavier. When they get too heavy, the water falls back down to earth again. That is what rain is. This cycle continues over and over.
Awesome.
And we also had our volcanoes as well. And that's when underneath the volcano there's the magma chamber. And the magma slowly comes up the main vent, which is basically a hollow tube in the center. And it rises due to the pressure caused by the leaves and everything. And then the magma reaches the top. It literally blows the top of the mountain, and it comes out as lava and goes down the mountain, burning everything in its path.
Excellent. All right. We done? Brit.
Just one quick thing.
Yep.
Between magma and lava is magma's inside the volcano, lava is outside the volcano. That's the only difference.
Excellent. All right. So, guys, this video, thanks to all of you putting it together, will be super important for your revision. It'll be up on the blog tonight. So, if you do anything this weekend, watch this. Exactly. I owe you 25 minutes, which I will pay you back next class, I promise. All right. Thank you very much. Thank you for being so committed. Yes. Sorry? You need to send it. Cool.